continuation with the previous topic. Now let's discuss about degree of unsaturation or double bond equivalence. So generally, let's proceed by taking few illustrations on this topic. So let's take our first example as C4H6. And first of all, before getting into the illustration, let me give a brief information on what is meant by unsaturation and saturation. Saturation is nothing but if an organic compound contains all single bonds, only all single bonds, then it is called a saturated compound. If it's an unsaturated compound, then the organic compound will contain single bonds along with double bonds or maybe triple bonds. Such sort of compounds are generally called as unsaturated compounds. Sometimes even rings makes up unsaturations. So if you take this compound C4H6, now if you want to find about its degree of unsaturation, or another time, or in some other books we call it as double bond equivalence, then firstly we can clearly understand here there is a double bond. If you look at its name, generally it's butane. In first step we must compare this butane with butane, in the sense this unsaturated compound must be compared with its saturated compound, like taking its corresponding saturated compound would become butane, of course. And now if you want to find degree of unsaturation, the difference between the number of hydrogens observed in saturated and unsaturated compound and its average gives the unsaturation or degree of unsaturation. So it's in here in this illustration we must say it's like 10 minus 6 by 2, it's like 4 by 2, and the degree of unsaturation becomes 2 degrees. Based on degree of unsaturation we can even write structures. So structures for the above formula or for the given formula becomes like CH2 CH CH CH2, or why not this structure, and we can even take this structure also. And shifting this becomes in the middle, we can write another structure, and we can even take ringed structures like butane, in the sense 4 carbons, yes, as taken, and 1 double bond, or this. Okay, in order to simplify, let's take another example. So let's take example with C3H4, and we must, in first step as I've told, we must compare it with its corresponding alkane. It becomes C3H8, and the difference 8 minus 4 by 2, 4 by 2 gives its 2 degree of unsaturation. Now if we write structures for this compound, this becomes DBE, and the structure for this compounds is like CH2 double bond C CH2, or CH3 single bond C triple bond CH, or maybe cyclic compounds even. So now let's take a compound which contains a halogen. How about it? C4H4X2. It seems pretty interesting. What do we do now? Yes, over here also in this case, one halogen can be considered as equivalent to one hydrogen for knowing the degree of unsaturation only. So it makes the formula like C4H6, and now we must compare this with the alkane C4H10, and the difference 4 by 2, it makes it 2. And now based on this we can even write structures like this: CHX double bond CH single bond CH double bond CHX, and we can even assume the structure to be like CH2X C triple bond C CH2X, and why not, sure, just like this we can even write here also another double bond and halogen, right? Let's continue in the next page. So let's take another example like this of C4H4O. Now this is becoming pretty much interesting, right? We've come to know that one halogen equals to one hydrogen. Then what about oxygen containing compounds? In the first lecture we have discussed that carbon and hydrogen does not even make up organic compounds, and the derivatives even like oxygen, phosphorus, halogen, sulfur, right? These even make organic compounds. So now what's the question, what my question is, that is, what about oxygen? Simple answer, no effect. Oxygen doesn't affect the degree of unsaturation, so hence a formula must be taken as this and compare it with its saturated formula like C4H10, and the double bond equivalence or degree of unsaturation becomes 3 degree. 10 minus 4 makes 6, 6 by 2 gives 3, and we can take this structure as like this. Yes, now let's take few more examples. What if, my question now is, what if, before taking few examples, now my question is, what would you do if they have given like a huge number over here and here, and they've asked you to find out the same degree of unsaturation? It would be pretty difficult, right? So in order to clarify that difficulty, now let's follow a very secret tip, that is, to calculate degree of unsaturation, if they have given a compound, one double bond makes 1 degree of unsaturation, triple bond makes 2 degree of unsaturation, one cyclic ring makes another degree of unsaturation. You must remember. And if they have given stupid compounds like this, which contains halogen, which contains oxygen, which contains nitrogen, and let's take an example of nitrogen right here itself, C4H5N, and compare this over here. One nitrogen means negative of one hydrogen. Remove the one hydrogen from this compound, it makes C4H4, and compare it with saturated compound C4H10, and I shall leave you this for the homework. Do the rest and find the degree of unsaturation, and the answer will be like 3 degree of unsaturation. So they might give oxygen, halogen or nitrogen. If these compounds are given, then you must follow the same old procedure. If not, you can follow this step. Based on this step, now let's try to do some questions. In the first class we have taken anthracene, like 3 benzene rings, right? So then, as I've told, yes, this makes 1 degree of unsaturation. 1 2 3 4 5 6 7 8 9 10. So the double bond equivalence over here is 10. And similarly, let's take in benzene. Over here it seems to be like 1 2 3 and 4. Double bond equivalence makes 4. And you can do homework for naphthalene. And now try to do for this vinyl benzene, or so called as styrene. It's exceptional name. This is called as styrene, note it down, or vinyl benzene. Yes. Now 1 2 3 4 5, double bond equivalence is equals to 5. Yes.